Assalamualaikum everyone. In today's video, we'll discuss the topic moments, which is the subtopic of Unit 1 of Physics, which is General Physics. So code for O-Levels Physics is 5054, and moment is one of the subtopic of the General Physics, which is Unit number 1. So let's get started. Firstly, you should know the one other name of moment, which is the turning effects of forces. Okay, then what is the definition of moment? Moment is defined as the perpendicular force and the perpendicular distance between the force and the pivot. So moment is defined as the perpendicular force and the perpendicular distance. So the force should be perpendicular. However, the distance should also be perpendicular to the pivot. Example, this is the pivot as well as this is the force. So the distance should be perpendicular to the pivot as well as to the force. So this is the definition of moment. You need three things to calculate moment. First one is force, second is pivot, and third is the perpendicular distance between the force and the pivot. So this perpendicular is the key word, perpendicular distance, force and pivot. Then we have the formula to calculate moment, which is moment equals to force into perpendicular distance, or you can say simply distance. Its SI unit is Newton meter or Newton centimeter. Then what if when you rearrange this formula, you can see that force is directly proportional to moment. However, force is inversely proportional to distance. Inversely proportional means when one quantity increases, the other one decreases. Indirectly proportional means when one quantity increases, the other also increases, or if one decreases, so other also decreases. So force is inversely proportional to distance. If the force increases, the distance decreases. If the distance increases, the force decreases. When the force increases, the moment increases also because it is a directly proportional. It has a directly proportional relationship with the moment. Then we have six cases. This is case number 1. In this case, you can see this circle is the pivot. I have labeled it P. D is the distance and F is the force. So distance from the pivot is perpendicular. It is making a 90-degree with force is towards downwards. So this is the simplest case in this chapter of moment. Then we have case 2. Here you can see that the line, or you can say the rod. This is the rod which is going straight. And here is the pivot which I have labeled P. Then the distance should be perpendicular to the force. Then we have case 3, in which you can see that there is the pivot and here is the force. Now you need to make the force, you need to calculate the distance. So here are some steps to calculate the distance. Firstly, this first step is to extend the line of the force, and the second step is to make a 90-degree from the force to the pivot. So according to the first step, you need to extend the force line. Let's extend the line of the force. So this is the force line, and I will be extending this line. Now the second is make a 90-degree from make a 90-degree from the force to the pivot. So from the force to the pivot, make a 90-degree. So it goes like here, here. So no, this isn't a 90-degree. So yes, it is making a 90-degree. First extend the line of the force and then join it with the pivot. So at this point, when you have extended the line of the force, you have to join it with the pivot. So here it makes a 90-degree. So this is the perpendicular distance. And then we have case number 4. In case number 4, you can see that this orange circle is the pivot. This is the force, and force is acting upwards. So first you need to extend the line of the force. As it is extended, the force is upward. Then you have to join the pivot with the extended line of the force. This is the distance as it makes a 90 degree, and this is the force. Then we have case number 5. In this case, you can see that the diagram seems a little tricky, but it isn't. The pivot is here and the force is acting towards the right. For this, firstly, what you need to do is to extend the line of the force. You extend it. You can extend the line of the force towards forward and towards backward, wherever it is needed. Then this is a pivot. Then you have to join the extended line of the force with the pivot. So this was extended line, and now you have to join it using the extended line with the pivot with the extended line of the force, and this is the perpendicular distance as it makes 90 degree here. Then we have case number 6. The case number 6 is same but opposite. In this case, you have force acting towards up, pivot is also up. The force is acting towards upside. So firstly, you need to extend the line of the force and then join pivot distance, pivot from the line extended. So this is the pivot. The distance you found is the perpendicular distance as it makes 90 degree here. So we can say that moment is directly proportional to the distance. The formula is moment equals to force into distance. Moment is directly proportional to the distance, and moment is directly proportional to the force. And moment directly proportional to perpendicular distance PD, or you can say simply distance. And then we have another case. In this, you can see that the pivot is present here, which I have drawn using orange color. And this is the force line, which is extended towards back. So when the force line is extended towards back towards the pivot, so it passes through the pivot. So the moment is 0 as the distance is 0, or you can say the perpendicular distance is 0. In this case, here is the pivot P, and here is the force. So when you extend the force line towards, for example, forward and then towards the backward, when you extend this force line towards backward, it joins with the line of the pivot. And when it joins with the line of the pivot, the perpendicular distance is 0. And when the perpendicular distance is 0, the moment is also 0. Because if the force is given, for example, 10 Newton, and the distance is 0, in such drawing or diagram is made given in the question. So distance, the force 10 into 0 gives answer 0. That's why the moment is 0. Then we have second topic of this chapter, which is the principle of moment. You need to memorize this principle of moment, or just you can remember this in your mind and rephrase it in the exam. So the principle of moment says that for anything to stay in equilibrium, sum of clockwise movement about a pivot is equal to sum of anti-clockwise movement about the same pivot. Okay, so this was the principle of moment for any object to stay in equilibrium. Means if the object wants to stay in equilibrium, so the sum of anti-clockwise movement about the same pivot should be equal to sum of clockwise movement about the same pivot. So to verify this principle of moment, we have an experiment. And experiments usually come in P4, and sometimes it can come in P2 also. So the experiment is this, that this is a rod given here, and we have attached a W1 or weight 1 at the left side. And here is the pivot, and the distance is D1, where the W1 is attached, the perpendicular distance from the pivot to the force, which is D1. Now what you have to do is to attach the W2 or weight 2, and this weight 2 can move, it is movable until the anti-clockwise movement and clockwise movements are equal. So at the distance where the anti-clockwise movement and clockwise movement are at equal, at that distance it verifies that the principle of moment is verified. So the equation to verify the principle of moment is F1 means force 1 into distance 1 equals to force 2 into distance 2. And this equation satisfies the principle of moment, means when the anti-clockwise moment equals to clockwise moment. So this was all about moment. I hope you understood it. Thank you.